Alright, hello, welcome back class. This is Unit 8 review. I'm going to go over pretty much everything here and make sure that we're comfortable with what we're doing for the exam. So, in this first case, we're going to be simplifying the expression. And so, right away, we'll notice that the index is 3, so we'll want 3 factors of something. Because it's odd and negative, we can pull out a negative. This is 5 and negative 1, 25, which is 5 times 5. We got a negative 1 in there, so we could pull out a negative 5. Then if we look, we have 3 factors of x, so we can pull out an x. Y to the 7th, so there'd be 2 groups of y. And then the same for z to the 6th, so 2 groups of 3 could go in there, so z squared. And then what's left is just a single y, because there was one left over here. So that would be simplified down. Next we have adding roots or radicals where we need the terms to be the same, so we need to simplify this as well. So I notice 81 factors down to 3 times 3 times 3 times 3, and we need 3 factors here, so we can factor 1 out. And then what's left is a 3 and an x here and here, plus this side as well. We can factor out an x, so that'd be 2x cubed and 3 times x. So now our terms are the exact same, and we can add the coefficients, which would just be 5, and then we rewrite the term. So that would be simplified like that. Now we have a product, to a power. So when we have a product here to a power, we're going to distribute the power to each part. And when you do a power to a power, like it'd be 27 to the first to the third, you multiply them. So that'd be 27 to the third, x to the first, and y to the 2/3. Now we can simplify. I can rewrite 27 to the third as the cubed root of 27. We'll leave x alone, and we will leave y alone because those are simplified. Now we'll see if we have 3 factors of anything, and we do. We have 3 factors of 3. So we can pull that out and rewrite what we have left. So this simplifies to 3x y to the 2/3 power. Okay, so now here, this is a little new, but the same properties hold. If you have the same index, you can multiply what's underneath, and the same goes for the quotient. So we can multiply and divide everything under the same index because they all have an index of 3. So it'd be 4 times 3 over 9. Now I'm going to see if I can simplify anything before I multiply, and we can. 9 over 3 will simplify to 3 over 1. Now when I rewrite it, this is the cubed root of 12 because it was 4 times 3 over 1. 4 times 3 is 12, and we can leave it like that. We won't have 3 factors of anything, so that'll simplify that quickly. Now in this case, it is combined, so we're going to see if we can simplify inside. We cannot. 27 and 2 do not have any common factors. We can, however, break it apart to the cubed root of 27x to the third over the cubed root of 2. This top 27, the cubed root of 27 is 3, and x to the third, we have 3 factors there, so that'll factor out like that over the cubed root of 2. Now we need to rationalize it because we have our root in the denominator, so we're looking for 3, or the third root of something over the third root of something. We already have 1 factor of 2, so we need 2 more. So we can multiply by the cubed root of 4 over itself, and in the numerator it's 3x times the cubed root of 4 over, well, we'll have our 3 factors of 2 right here, 1, 2, 3, and we need 3, so that would just simplify to 2. And that's how that one would simplify. We're going to skip past these. Okay, so again, we do not have the same base in this case, so let's rewrite it. We don't have the same base, or the same index. We do have the same exponent, but let's rewrite it in exponent form. So that'd be 9 to the third times 27 to the half. Now what we can do is we can manipulate these bases to be the same. 9 can be rewritten as 3 squared, because 3 squared is 9. So if I rewrite that with this third power, that'd be 3 to the 2/3 power. Because it would still have a 1/3 power here. I just rewrote the 9 in the numerator here because 3 squared is 9. I can do the same thing with 27. I want the same base. I want a base of 3. 27 is the same thing as 3 cubed. So we're going to do the same type of thing. Multiply it to the top. And that becomes 3 to the 3/2 power. These are equivalent and these are equivalent. I just changed my base so that now I can do my operations. When my bases are the same, I can add my exponents. So 2/3 plus 3/2. I need a common denominator. So I can find one at 6. So that becomes 4/6 plus 9/6 equals 13/6. You'll also notice my fraction is improper. So I have some more factors of 3. So when I rewrite it in root form, 3 to the 13th. Well, how many times does 6 go into 3? Excuse me, how many times does 6 go into 13? 2. So we'd have 2 factors of 3 we could pull out with 1 remaining because there's 13. So there'd be 1 left. We can simplify this to 9 times the 6th root of 3. And we could do the same thing now with the quotient. Our bases are not the same, but we can manipulate it to be the same. So if we think 8 is a nice cubed number, that's 2 cubed. So I'm thinking our bases are going to want to be 2. So we'll have 2 to the 3/2 power over 2. Well, 2 to what power is 4? 2 squared is 4, so it'd be 2 to the 2/3 here. Because I put my squared in the numerator, so it's 2 to the 2/3. Now I have a common base, and I can, because it's a quotient, subtract my exponents. Again, we have the same situation where we need a common denominator. It's the same type here. So we already know that this will become 9/6 minus 4/6, which is 5/6. That's a proper fraction. It's positive, so it'll stay in the numerator. So that becomes 2 to the 5/6 power. This one here, what we do not want to do is rewrite this as 3 over 1. We do not take the reciprocal of the exponent. When we take the reciprocal and it's a negative exponent, everything gets put in the denominator here, if it's a quantity like this to this power. So that's 27x cubed to the now 1/3 power. It's now positive is what happened. Now we have a quotient to a power, so we can distribute the quotient to the top and the bottom. 1 to the 3rd power would still be 1. We'd have 27 to the 3rd power and x to the 1st, because it'd be 3 times a 3rd. 27 to the 3rd is the same thing as the cubed root of 27. So we need 3 factors. These should start to look familiar. So we have 3, so that's 1 over 3x. That's how this one will simplify. All right, what square root simplifies into 3x squared times the square root of 2xy? I understand if that can sound confusing, but it's asking what square root simplifies to that. So what square root simplifies to this? Well, what we want to do is square it. We want to do that inverse operation, and then we can reverse it, and it'll simplify to this. So the inverse of square root is squaring, and this is a product here, so we're going to want to go to each piece. So this would be 3 squared times x to the fourth times, well, square root and squared are inverses, so all that's left is times 2xy. So 3 squared is 9. We have a same base here, x and x, so we add them. 4 plus this exponent would be 1, x to the fifth times y. If you want to check that what square root simplifies to this, let's reverse it. So it'll be the square root, whoops, look at this, I forgot a 2. This 2 is still here, so we can multiply 9 times 2. So we're not quite done yet. That'd be 18x to the fifth times y. All right, so that's what we're going to want to take the square root of to check. We should get this out. Y, so 18 is 9 times 2, which is 3 times 3. We need 3 factors, so we can pull that out. X to the fifth, we can pull out 2, and then what's left is 2xy. So let's verify. 3x squared times the square root of 2xy. 3x squared times the square root of 2xy. So if it asks you what square root, square the whole thing. That will then be your final answer. Not this part. That is not quite it. This is your final answer. So we're going to check for extraneous if needed. Since we have the cubed, we should be fine here. So an inverse operation would be cubic, or the cubed root. So x minus 5 equals 125 is 5 times 5 times 5. So add 5 to both sides, so we get x equals 10. If we plug that in, we would get 10 minus 5. 5 cubed is 125, so that looks good. Inverse relation. This is the same thing as y equals. Now we can flip y and x. 3/4 y minus 9. So we can add 9 to both sides. X plus 9 equals 3/4 y times by 4/3. That's our inverse here, because this now will simplify to 1y. And we can distribute this to both pieces here. So we have 4/3 x plus, it'd be 4/3 times 9 over 1. I could have just written 9, but I'm trying to emphasize that we multiply straight across with fractions. We can simplify this here to 3 over 1. So that's 4/3 x. In the numerator, it would be 4 times 3, which is 12. And then finally, that is my inverse, so we need to write y inverse equals 4/3 x plus 12. I'm going to leave this one. Next, we're just stating the domain and range. From the function, you should be able to tell that this is a square root function. The parent function would be the square root. So my domain will be x is greater than or equal to, because it's continuing on to the right, 2, that's where it starts. And my range will be, it's increasing, and it's starting at a height of 0. So y is greater than or equal to 0. Another square root, I'm going to leave that one. If it's cubic, this is the cubed root. It continues left and right forever, and it continues up and down forever. So my domain would be x is an element of all reals, and my range would be y is an element of all reals. All right, and then now we can practice graphing. My leading coefficient is a -1, so a is -1. So when I make my xy, ay table here, we want to see what would be some nice input values. It's the cubed root, so we want nice cubed numbers. So that would be -8, -1, 0, 1, and 8. We can have negative numbers when it's the cubed root. Those numbers, when you take the cubed root, would be -2, -1, 0, 1, and 2. Finally, we want to multiply my y column by a. We're scaling it by a factor of a, which is -1. So that would be 2, 1, 0, 1, and 2. So we no longer need this column because we're going to be using my XAY to plot points. We still, however, need to see if there's a shift, and there is. My HK is the opposite under the radical, so that's -2, and then we keep the sign for my K. So my HK, my new origin, would be -2, -4. So -2, 1, 2, 3, 4. And then from my new origin, we shift around the graph from my XAY, not from the original, not from the origin. We now shift from here. So back 8, up 2. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. And then it'd be -1, 1. And 1, -1. I see what I did. And then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. And this looks cubic. And then finally from here we can state the domain and range. Since it's cubed root, x is an element of all reals and y is an element of all reals. Let's look at a square root. My a is 2, so it's going to be vertically stretched. X, Y, A, Y. We can also list my HK first. It's going to be 2, -3 based off H and K. This is my new origin. So 2, 1, 2, 3. Since it's a square root, they need to be greater than or equal to 0, and we want nice squared numbers. If you'll notice, my inputs are nice squared numbers, so that when I take the square root, it's 0, 1, 2, and 3. And then my a was 2, so we need to scale my y by a factor of 2. 2, 4, 6. Now we get rid of my y column. We can draw a new xy axis through if we want to emphasize that it's my new origin is this point. So this is 0, 0, 1, 2. It's 1, 2, 3, 4. 1, 2, 3, 4, and then 9, 9. 9 would just be or 9, 6. 9 would just be off. 1, 2, 3, 4, 5, 6. So that's my square root function here. My domain, when it's a square root, you're going to use your HK as indicators. My values are increasing for x. So x is greater than or equal to 2. That's my h. And we can also see that it's to the right 2 on the graph. My y values are also increasing. And my k is -3. Let's verify with the graph. It's at a height of -3, 1, 2, 3. And it's increasing. So greater than or equal to that point. Okay, so now some solving. We've done this most recently. We already have our root isolated, so we're going to want to square both sides since it's a square root. Do the inverse operation. So 3x equals, to save some time, I'm going to quickly distribute this. It's x squared minus 12x plus 36. That's when I distribute and multiply x minus 6 times x minus 6. We want to set this quadratic equation equal to 0 because that's how we will factor it. So x squared minus 15x plus 36. Some nice factors that multiply to a positive 36 and add up to a negative. So since we're multiplying to a positive, the signs must be the same. So x minus 12 and x minus 3. Let's check. -12 times -3 is 36. When we add them, we get a -15. Okay, so that means x equals 12 and x equals 3. And finally, we must check if they are extraneous. So let's check 12. We would get the square root of 36 equals 12 minus 6. Does 6 equal 6? Yes, so that's a real solution. Let's check 3. The square root of 9, I took 3 times 3, equals 3 minus 6. 3 equals -3. No, that is not true. This is extraneous. Let's do this one. Let's see, how many do we have here? I will do this one here. This looks like a good one. We're going to subtract both sides by 2. That's my first operation we're going to want to do. So we have 3 times x minus 1 to the 3/2 power equals 24. Then we're going to want to divide both sides by 3. So x minus 1 equals 8. Oops. To the 3/2 power. Now we can rewrite that exponent as a root. My index is 2, so it would be the square root of x minus 1. And my exponent is 3, so it would be cubed. Now to take the inverse of this, if it's cubic, we're going to want to take the cubed root of both sides. So the square root of x minus 1 equals the cubed root of 8 is 2 times 2 times 2. Now we can square both sides, so x minus 1 equals 4. So x equals 5. If we plugged in 5, we would get 5 minus 1 is 4. When we take the square root, it's 2 cubed is 8. 8 times 3 is 24 plus 2 is 26. Good. So that one works out there. If you want to check by yourself, I would do so because I went through it a little quick. And then finally, we have composition of functions. So when we compose h of e of x, we need to plug in e of x where x is. So that's this. So let's put our parentheses to emphasize it. So it's the square root of x squared plus 3 minus 2. We can simplify that to x squared plus 3 minus 2. And then combining like terms, we get x squared plus 1. That's that composition. Now let's do the other way. So now we are plugging in h of x, this whole thing where x is here. So I'm going to do parentheses again just to emphasize. So that's the square root of x minus 2 squared plus 3. The square root and squared are inverse operations, so that simplifies. So all that's left is what's underneath, x minus 2 plus 3. We still have this on the outside. Now we can combine like terms again, and we get x plus 1. All right, thanks for watching. Let me know if you have any questions. If you want me to go through the other ones, be sure to ask, shoot me an email, and good luck for the exam. Okay, see ya, bye.